Hello students, it's me, your instructor Al Trujillo, and I am going to record a short video for you to cover one of the most difficult to understand topics in Chapter 7, and that is the differences between eastern and western boundary currents of all subtropical gyres. So we've been learning in class about these subtropical gyres and that there are four main currents within each subtropical gyre. The eastern and the western sides of those subtropical gyres have very different characteristics, and that's what I wanted to point out and explain in this short video. So let's do this. All right, so the it's called western intensification. All subtropical gyres experience this, and we've been learning in class that we have 5 different subtropical gyres in the world. So the North and South Pacific Oceans, North and South Atlantic Oceans, and the Indian Ocean comprise the 5 main subtropical gyres. Now, in each one of these subtropical gyres, the western boundary current, so the western side of the gyre, have these characteristics. So these currents, surface currents, are fast, they are narrow, and they are deep. And this is true in either of the 2 hemispheres, so northern and southern. It's true whether you're in a northern hemisphere subtropical gyre or a southern hemisphere subtropical gyre. And it's also interesting that the eastern boundary currents on the opposite side, they have the exact opposite characteristics. So they're not fast, they're slow. These currents aren't narrow, they're wide. And these currents, these eastern boundary currents, are not deep, they're actually quite shallow. So I wanted to explain a little bit about why that is, and to do that we need to understand a little bit about the geography of an ocean basin. So let's take a look at the North Pacific subtropical gyre as an example here. And there are 4 main currents that flow into one another. For instance, the California current off the coast of California flows into the North Equatorial current, which flows into the Kuroshio current, which flows into the North Pacific current, and back around to the California current. So this is this giant loop of water that's about 6,000 miles across that goes around in a circle, hence the term gyre. All right, so let's just take a look at the geometry of this here. And here's the middle of the gyre. So this is the geographic center of the gyre. So if you were here in a boat in the middle of the gyre and you were going to go this direction to the right here, would you be going east or west? So again, just from the middle of the gyre, being on a boat here, you wanted to sail this way to the right. Would you be going east or west? And the correct answer on that is you'd be going east. Like, for instance, if you were in San Diego and you were going to the right on a map, you would be traveling towards the east here, okay? So that's the east. And that's why the California current is an eastern boundary current. Now, I know how confusing this is because I know it's off the west coast of North America, but my advice to you is don't look at the continents. Don't consider the continents. This is an ocean basin perspective. So ignore the continents, just look at the gyre, which exists in the ocean. And from that, we can see that the direction to the right here is actually going to the east. So that's why California current is an eastern boundary current. Let's go on the opposite side. What if you were out in the middle here and you were going to the left here? Would this be east or west? Just the direction that you're traveling. And the correct answer for that is, of course, you're going west. You're going left or to the west here. And that's why the Kuroshio current is what's called a western boundary current. Now, I know it's off the east coast of Asia. That's why this is confusing. But again, don't consider the land. Consider only the ocean basin and the directions within the ocean. Now, if we were all dolphins, I wouldn't have to explain this to you. You would know because you're only familiar with the ocean. But we live on land, and that's why this is confusing. So, again, the California current, eastern boundary current. Yes, I know it's off the west coast of North America. Don't think about it that way. Think about it only in relative perspective to the ocean basin in which it resides. Kuroshio current, yes, I know it's off the eastern coast of Asia, but it's a western boundary current when you consider only the ocean basin. So just a little bit about geography, and I think this is where a lot of students get confused. Is it eastern or western? Look at just the ocean basin, not the land. Okay, so let's get rid of those annotations. And here's our same middle of the gyre here. And we know the Earth rotates towards the east. So it's rotating to the right here, towards the east. And the analogy I like to give is, what would happen if you had a bucket of water and it's in the back floor of your car and it's full of seawater, and you're at a stoplight, the light turns green. Well, you accelerate. When you accelerate, then what's going to happen to the level of that water? Well, it's going to slosh out. It's going to move towards the back. And in a similar way, because of the Earth's rotation, that it's rotating this direction here, the middle of the gyre is actually shifted, not the geographic center, but the rotational center is now shifted over to the left or the western side. This is really the root cause of western intensification, by the way, is the rotation of the Earth causes the center of the gyre to be shifted over to the western side of the subtropical gyre. And this is true in either northern or southern hemisphere. So let's take an example here, and let me get my pointer, show a pen here. And let's say you're here off of San Diego, and you're in a boat, and you're out a little bit offshore, and all of a sudden you lose power, and you have no sails, so you're just adrift in the ocean. And what would happen is you would be moved with the California current in this direction. And this is true based on studies of bottles, of drifters, also of boats that actually do get stuck, any kind of a floating object. It depends a lot on how far above sea level the object rises up, which is called windage. If it has a higher windage, the wind blows it faster. But what happens then, as you get here, you're being pulled by the north equatorial current here, and you don't really have much of a tendency to be curved up to the right. You don't really do this. Why not? Well, what do we know about the Coriolis effect? It's to the right in the northern hemisphere, but remember, it goes to zero along the equator. So here we are very close to the equator, not much of a tendency to curve the right. So you just keep going with the north equatorial current, and you'd be moved along like this. And by the way, this exactly happened to a group of fishers in a small panga, a small boat off of Mexico. They spent about 10 months out here in the open ocean. They had a motor failure, and they had no sails, and they were just adrift, and were finally picked up about 10 months later right over here in this location right here. So, there's many cases where we know this to be true. Messages in a bottle, those kinds of things as well. So what would happen is you would stay with this north equatorial current until the whole mass of it started to turn, because it comes up against the east coast of Asia. So then you turn, and you would follow this path, kind of like this. You would be moving in this kind of a path. And so what happens with this, if I can get my mouse to work right, is that now you're up at a higher latitude. So now you would have more of a tendency to curve to the right. So in essence, what would happen is you would shortcut the loop. Notice we're shortcutting around the center of the gyre. So I'm going to draw this for several passes through this here. Again, it's going to take quite a while to do this, but you would shortcut in a different place just about every time on the right side. Sometimes you go far out and curve around. Other times you would go, and again, this is taking many, many years to do this. You shortcut a little closer in and move around like this. And then sometimes you might swing across the whole length of this. Help! Help! Too late, you're back in there. But the point of all this is that on the left side, on the west side, you're cutting back through in just about the same place. Whereas on the eastern side, what you're doing is you're cutting through at different locations here. I might have misstated that. It's on the western side, you're cutting back in just about the same place. And the eastern side, you're cutting back in a variety of different places depending on how far you go before you start curving. So this is the kind of path you take if you were in a boat after many, many, many years. You'd shortcut through in a variety of different places here on the eastern side, and then on the western side you go just about in the same place. So notice how it's all centered around that middle of the gyre, which is now shifted to the west. So this is the kind of path that you take over many, many, many years if you were adrift in the North Pacific subtropical gyre. So the important point to notice about this, the middle of the gyre is shifted over here on this side, and as a result it forces all this water, like the narrow area of a funnel, to be transported along a very narrow area, whereas on the eastern side you're shortcutting back in a variety of different places to complete that loop. So that's exactly what happens there. Let me get my pointer back to an arrow there. There we go. And so that's kind of what it looks like. Here's a more detailed explanation of it. But notice here the rotational center of the gyre. It's not in the geographic center of the gyre. It's shifted over to the west because of Earth's rotation to the east. So there's a more detailed description of this in terms of what's called geostrophic flow that's in the book, and it's in this figure 7.8. So you can have a look at that as well. But in essence, there's a shortcutting of the water. So as the water shortcuts, it's over a much wider area, and that's why on the eastern side of an ocean basin in these subtropical gyres, you have a slow current, you have a wide current, you have a shallow current. Whereas on the western side, all this water in this wide area of the funnel is moved through a very narrow area, and that's why they're fast, they're narrow, and they're deep. So that's really why we get western intensification. So let's take a look at this, and when you look at a map like this, you kind of have to imagine which direction or which location each one of these eastern and western boundary currents is. So let's take a look at the Gulf Stream. So here's the Gulf Stream, and is that an eastern or western boundary current of the North Atlantic subtropical gyre? Well, if you're paying attention here, this would be on the left side or the west side. So the Gulf Stream is a western intensified current. I know it's off the east coast of the United States, that's why it's confusing, but it's a western intensified current. And as a result then, would it be wide or narrow? Would it be deep or shallow? Would it be fast or slow? And those are the kinds of questions you're going to have to answer for the exam. So be prepared on that. Let's take a look at the other side. How about the Canary Current? Is this an eastern or western boundary current? And again, because it's on the right side of an ocean basin, that would be then the eastern side. So it's not western intensified, it's an eastern boundary current. And so the questions you'll have to answer is it wide? Is it narrow? Is it fast or slow? Is it deep or shallow? So those are the kind of questions that you'll have to answer. What about the Brazil Current down here? Is that an eastern or western boundary current? And the correct answer to that is that's a western boundary current. Remember, it's true in both hemispheres, eastern or western, are the same side, whether it's northern or southern hemisphere. So Brazil Current, is it wide or narrow? Is it fast or slow? Is it deep or shallow? And those are the kind of questions you'll have to answer. What about the Peru Current? Is that an eastern or western boundary current? So I think that's probably the easiest way to figure these out, is first to decide, is it an eastern or western boundary current? And the Peru Current is, of course, it's on the right side, so it would be an eastern boundary current. Is it fast or is it slow? Is it wide or is it narrow? Is it deep or is it shallow? And here's an additional question that you'll have to answer as well for the exam. Is it cold or is it warm? And the answer to that is, well, you can see because it's a blue arrow, that's a cool current, but look where it's coming from. It's coming from near Antarctica. It splits off the Antarctic circumpolar current, and it splits off here. And as a result, it's carrying cold water. There's upwelling associated with it as well, but the Peru current is a cold current. What about the California current? Is it a eastern or western boundary current? And from our previous discussion, you know it's an eastern boundary current. Is it wide or is it narrow? Is it deep or is it shallow? Is it fast or is it slow? So those are the kinds of things. And the other question is it warm or is it cold? And the answer to that is it's a cold current. You can tell by the blue arrow, but look where it's coming from. It's coming from the North Pacific Ocean. So those are the kinds of questions you'll have to answer. Here's a tricky one. Here's the East Australian current. Is it an eastern or western boundary current? And for those of you that are Finding Nemo fans, the EAC is how it's talked about in that movie, which is geographically correct, by the way. So the EAC, is it an eastern or western boundary current? And this is one of my favorite test questions because the EAC is actually a western intensified current. Remember, it's on the western side of the South Pacific subtropical gyre. So that's kind of tricky. The EAC, East Australian current, is a western intensified boundary current of the South Pacific subtropical gyre. So why did it get named East Australian current? Because we live on land. It's off the east coast of Australia, although if we were dolphins, we would know that as a western intensified current. So, again, same questions about that you'll need to know. First of all, is it warm or cold? Look where it's coming from. It's coming from the equator, so it's a warm current. Also, the red color indicates that. But is it fast or slow? Is it wide or narrow? Is it deep or shallow? So those are the kinds of questions that you'll need to figure out for answering questions correctly on the exam. Where would you find this information? This is Smart Table 7.2, so it's got its own recording about it that you can listen to. But this gives you some information about western and eastern boundary currents, gives you some examples. We're talking about, is it wide or is it narrow? And this gives you some numbers here. Is it deep or is it shallow? It gives you some numbers here. Speed, it gives you some numbers here. The transport volumes, again, large for a western boundary current, small for an eastern boundary current, and a few comments about it. So this will help you organize all those eastern and western boundary currents. So be prepared for that on the exam about questions for various currents, whether they're eastern or western boundary currents of the 5 subtropical gyres and what the characteristics are. I hope this has been helpful to you. Thanks for listening.